Okay, recording. Okay, so uh, actually, okay. Today we're gonna make an executable. That's my understanding. Oh, and I should also mention, Benes shared that apparently in Erlang, not Erlang, OTP 29, there are now recommendations of the OTP people to make a language on the bean.
I saw that. That's very nice, actually.
And we are not compliant fully yet because we don't generate the abstract format files,
I mean, they
which
say we should do that or invoke the compiler, right? Which we are doing the second option, but I think emitting the file is nicer because then you can inspect it more easily.
yeah, but I like that's gonna be unreadable, man. Really, especially because we don't format anything. We just like append them. So like seems a little wasteful. Anyway, so that's fun. And today we're gonna make an executable, I guess, right? Because we need to put an entry point.
We do, indeed.
Okay, so I think that's what we agreed we should do as the first thing. There are many things we should do that I already forgot. We need to do an entry point. We need to. What were the other steps?
We need to do an entry point. Are we already saving the state to generate the initialization function already? I don't think we are, right?
Saving the state for the initialization function. What do you
Actually,
mean
we
by
may
that?
be. First functor arg. Oh yeah, no, that's the last thing we did last time, actually.
What do you mean by that? I don't know if I got it.
This, we're collecting the
Ah,
schema
the
names as
mutable
we go.
stuff. Ah, the mutable
Yeah.
stuff. No, 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 no. But I was talking about the steps after entry point implementation, like after executable. There were more steps.
Okay, we need to make the executable. Oh yeah, we need to actually emit the Sakura code because right now we're not actually compiling the declarations.
Ah, yeah, that is true. That is true. Well, but are those only the two things missing, right? Or not? We have more?
Uh, let's see. We need an entry point. We need to compile the Sakura declarations. We need to. I
We
guess
need to.
technically we need to
Ah,
implement all
I
of the
remember.
directives as well.
We need to save the. We need to dispatch stuff to the counting runtime. Yeah, I remember that. I remember that.
What do you mean by dispatch stuff to the current runtime?
I mean grabbing stuff, grabbing configurations that the OCaml code only the OCaml code can know, such as via the CLI or project directive, and piping that down all the way to the start function in coding.
Yeah, that will be part of making the entry point. Because the entry point is where we emit the actual call to start.
Yeah, and we agreed that we're gonna make some dummy lets on the main.ml, and we're gonna pass down those downwards like it was supposed to be done via CLI. That can be done later. And yeah, okay. I think today is just entry point journey anyway. So let's focus on today.
Okay, so let's see.
My understanding is that this is gonna be the last thing the executor is gonna do, because executor separates the file paths with Sakura stuff and Karuta stuff. Then it preprocesses all of them. It does dependency checking on them. Then it compiles them, and then and then it starts. That's the last screwing thing, compilation. We just compile them. And all we gotta do is go to the CLI type on line 37 there, add the address and the port stuff to that, and destructure that, and at the end we create the entry point stuff with the final compiler version, right? Because after compilation we're gonna have a compiler, a full compiler.
So address and part number, right?
There is a problem. Um, I think my genius opinion is that we should make a Sakura record actually, because we may have CLI things that are not related to Sakura, like the log level, which interferes with OCaml stuff. So we should definitely make like a record inside a record here, and the Sakura record field should be optional because maybe you're not going to change anything via the CLI for Sakura. And there's the port missing as well. Should that be a string though? Hmm.
Well, I guess technically the part could be an integer. That would be not this.
Yeah. And all these records should be. I don't think you can do inline records inside records though. But we should search. I think, and this needs to be optional by the way. So it needs to be option at the end there. Anonymous records inside records OCaml.
Yeah, I don't think you can actually. It's the same thing as you having an anonymous record as an argument for a type constructor, right? That also doesn't work.
I don't really understand. No, no, I lied. I kind of understand why that works for EDTs. Yeah,
Well,
sure.
the short version is OCaml grammar is dumb.
Actually, I think we should make a module, to be honest. Maybe this should be a separate file. Not, they should not live in types, compiler types anymore. Maybe we should promote this to be like a full module and stuff. It's not really related to compiler in a way. Like
Well, those are the options that the compiler needs in order to do its job, right?
not necessarily. Most of them will be optional because the
Well, that's
compiler will
why
have
they're called
defaults.
options.
No, yes, but that means that there will be a bunch of nuns, right? So, well, if you want that, let's change the name of this type. It should not be CLI then.
Let's call these options, I guess. Actually, I don't like this name because it's not too. Well, I suppose
Configurable options, options
that sounds
config.
that sounds redundant. Hmm.
Yeah, I am on the team that this should be a separate module. We should have a CLI.ml. It could be inside of the compiler namespace, but this already has two types that are kinda like they're sorta related to the compiler, but not intimately related in my opinion.
Well, I guess. Let me undo all this for now. Okay, what types do we actually have here? We have predicate name forms, env and nested env. Yeah, most of these are actually in compiler internal types, right?
Yeah, yeah, they're not configurations, really. This is the runtime, if you think about it. This is the state of the runtime, I should say.
Of the compiler.
Yeah. So in my opinion, the CLI is kind of like a plugin. It's related but separate. So that's why I want to make a separate module for it.
Hmm. Okay, I'm going to put this here for now, but we can move it later if this is up, if this becomes too big.
But this already has two types. Like, why you don't like the idea of making this a separate module? Exactly.
Because that's another file that we have to look through.
But what's the problem with that?
Well, I'm not a big fan of switching context to look at things.
But you're not switching contexts. So it's the CLI context. So you go to the CLI module. We're not going to even open types.ml to do the thing. We're going to only do the other files that are the execution. We're not going to open this anymore, really.
Hmm.
Like there's a lot of stuff in here we're not going to be paying any attention to during this implementation. But we need the CLI type. And the Sakura inner type, I should say.
Okay, let's make this a nested module then. Module,
Okay, the noise is going to stay because it's a nested module. Sure.
module. Let's
CLI.
call it.
Oh,
Oh,
you
but
want to
this
make
is
these
not.
general options. Okay.
This is not necessarily gonna come from the CLI, right? This may come from a project file.
Well, how should I say? There is the CLI stuff and the options of the compiler. Those are two different types, really. The CLI will have things that the compiler really doesn't care, like the log levels, right? And there would be options that the compiler cares. And those are two different types. And then we're going to have to convert one into the other eventually.
Uh, well, yes. I
Yeah,
propose that the type here is for the options that the compiler actually cares about.
yeah, that's fine. So that's not really CLI, so I'm okay with that.
Options struct and then type t equals. Let's keep this empty for now.
And we need the type Sakura probably.
Uh, well, type Sakura.
Then this needs to have at least the address and the port and the module name.
The address is going to be a string. Module. Let's call it root
Root?
module. What do you think?
Sure, that's fine.
And then the port is going to be an
Uh,
integer.
okay, I need to ask a question. When in the pipeline we're going to create the type T of this module? Are we going to do that before calling the executor, or are we going to do that like when are we going to create this type?
Uh, right now we don't have a project file support, so the only place that this will be able to come from is the command line. So this should be passed. Like the executor doesn't actually parse the command line. That's done somewhere else, right?
Yeah, but okay, let me explain my motivation. I'm debating myself if root module should be optional because we have the DB default, right? So depending on where we're going to instantiate a value of of type T, that may change my answer if root module should be optional because we have a default. If we're going to do it before preprocessing, then this should not be optional because then we can make the default in the instantiating itself. But if this happens after preprocessing, then well, I guess the answer is the same. We always on the default, right? So this cannot be optional anyway.
Uh, Before or after preprocessing, this needs to be before, right? Because we need to know the name of the root module. Actually, do we?
I think it needs to be after. Well, I think it needs to be after because we need to know if there is a Sakura requirement in the project, right? We can infer that based on the files, on the existence of the file extensions. So if you haven't provided um, a root module via the project directive or the CLI, we're going to use the default. But if you haven't provided address and port via neither of those things, we need to error out essentially. So I think we can keep this as is right now, as it is. and then we can go to main.ml and let's do the mocks of the stuff.
Okay.
Oh wait, before that, just to prepare the boilerplate. Let's create the CLI type T because, like I said, those are different types. Because the
Do we have
CLI
a
will
CLI
be a
module already?
superset.
We don't, right?
Yeah, create a CLI.ml inside of the compiler. Actually, not inside of the compiler because this will have configurations for everything. So let's just put lib/cli.ml. Yeah. And then in here, we should have a copy-pasted version of the options for now.
Copy pasted.
Yeah, exactly the same. Maybe we can flatten in this case. Maybe we don't need the separation in this level.
Okay, I'm gonna copy it for now, but oops, that's not what I meant. CLI.
Yeah, you can remove the nesting of options. Yeah. So now okay, just for you to understand, we're gonna create options on main.ml right now. This is just here to prepare the ground when I refactor that later to be the CLI for real. Yeah, that makes complete sense. That is zeroing out. Go to main.ml first. No, that also works. Options, T. And that's still not gonna work because you have to destructure it properly.
Right. Um, I
Just
guess
grab the
technically
Sakura
we
stuff.
can do Sakura.
But we need to do a let. Before this let, we need to do a let to do shadowing on the optional stuff. Because this is optional, right?
It is actually. Uh, hmm.
If
I
this was lazy, that
guess.
would be easier right now.
I guess technically. Let's go back here for a second. Technically, um, yeah, this is not right. This is not the right level to make this optional. We should actually do this mandatory, but then in here,
I think I disagree. Because if you have a project that doesn't have any database things, you are forcing to have Sakura there, but I'm not using database.
mm,
Like if I have a script in Karuta, that's it. That's what I'm doing. I'm solving the chess screen problem thingy in Karuta.
uh, like I was thinking of doing something like this um,
That is better, I would say.
because then this can be optional. You see, because we will have a default root module name regardless, right?
Yeah.
Uh, but it
We
may
should
not actually,
we should
right?
probably do that right here. We should have a function called initialize Sakura that if you provide an optional root module and the connection stuff, and we can put the default of the DB here and remove from the
Huh.
executor.
You know, actually, maybe we shouldn't make this. Yeah, okay. So let um, what are we gonna call it? Make Sakura.
I would say initialize Sakura to be consistent with our stuff. You receive two things optionally. This could be optional arguments, by the way. You can do the tilde thing. So root module, and that default is going to be DB.
Root module. is going to be... Actually, I always forget how to do that. Question mark.
No, it's the type first, and then you have a separate syntax for the value.
Root module equals db if it's not provided, right?
Yeah. Then you also, and then you receive the connection, essentially, which can be optionally none, right? This can also be optional. Um, but this is kind of weird. You can pass a root module, but not pass the connection shit. This is allowing this scenario to happen.
Hmm.
I think I disagree. I think connection should not be optional, actually. I think you need to pass connection. If you're trying to initialize Sakura, you must have the networking information. So in my opinion, connection should not have a default value to none. If you want to initialize a Sakura, you must provide the connection stuff.
Okay, but then if the connection is mandatory, what is optional? The Sakura
Yeah, the
configuration
Sakura
completely?
itself needs to be optional, like line 98, I agree. And I think we
Okay.
don't need the option on connection anymore, really. Well, I
Well,
don't know if
then this
that's
doesn't have...
better because this is flattening it. Maybe we're gonna have more address stuff later. Because remember, we're gonna also put the timeout stuff later. We have many different timeout configurations in the LFE. So maybe having a separate type for connection was a good decision. But you have to pass one, right? So what do you think? We flatten it or we keep the connection stuff separate? I
Hmm.
think we should make it separate because we have at least 3 different timeouts later to put in here as a separate issue that I remember from the LFA code.
3 different timeouts. It's in here, right?
Yeah.
Time connect, send, and
There is another one in Sakura.
Sakura. Receive, yeah, receive timeout as
All of
well.
these needs to be configurable. So in my opinion, the connection type being separate to me is better.
Okay. Counterpoint, that's more nesting. Do we actually want more nesting?
I don't know what you mean. The type on line 100 is nested as fuck. This is already our rule of thumb. This is not only nested, it's recursive, mutually recursive with itself.
Hmm. You mean this, right?
Yeah, not only that, right? But we also have the comp times, and the comp times have more nesting, and we have ADTs and records, all of that nested as well.
But those actually have a natural reason to be nested, which is they are mirroring the module structure that the language allows the user to
No,
construct.
I agree that there is a stronger argument. I'm not saying it's a bad decision. I'm saying, and I agree that in this case the argument is stronger. But there is also the case of separation of concerns in here.
Is there really?
Well, of course, we could make these types a lot worse.
No, I mean for the Sakura thing specifically.
Well, I think the connection stuff is gonna blow the Sakura type because you're gonna put a bunch of specific connection stuff, and we know this already. We know ahead of time there will be at least five connection related fields in here, 3 timeouts and an address and a port, at least. So if we know
I mean,
that, do we want to
but they
blow
but
this?
they are but they are all related to the interface between Karuta and Sakura.
So,
Is that really a separate concern?
no, it is a separate concern in terms of Sakura, because Sakura has a root module which is 100% only compiler related, and there's networking things. And in the future, we may have, I don't know, load balancing concerns or optimization concerns, performance concerns, strategy concerns. I don't know, maybe in 2030 this is going to be distributed. Like there's so many things that are related to Sakura in its own ecosystem.
Ah,
But if you
well,
want
we
to
can
make it
change.
flatten, that's fine. I just think that's going to bloat the type very fast. I'm okay with like keeping it as it is, but I'm telling you that I'm going to change that in the future if we have like 7 fields in which 5 are related and 2 are not.
Hmm. Okay.
It's kind of the same the same sentiment that I have on type T of line 100. I also think that should be grouped. We already did this with lookup. I don't know why we didn't do with other things.
Hmm.
Let's continue. Let's continue. So initialize Sakura should receive address and port mandatory. That's the drill.
Okay, this needs to be like this then. Oops.
I'm confused. What's
Uh,
up with the tildes there? Hello?
it's because I don't want this to be positional, basically.
Ah, okay, that makes sense.
This optional argument cannot be erased.
What? What's that supposed to mean? Okay, this optional type cannot be erased, OCaml.
That's a very weird error message.
In OCaml, optional arguments are erased when the compiler sees a positional argument applied later in the function call. If a
But I
function
don't have
has only
positional
optional or
arguments.
labeled arguments, the compiler never sees a marker to tell it that the user is done providing optional ones. Wow, so this means that if you use the optional arguments, you need to have a positional, at least one positional another argument.
That is kind of silly, actually.
Well, there must be a technical reason why that's the case. Like, I may joke about the OCaml people, but the OCaml compiler people are very smart.
There we go.
Another
Problem
argument is to have
solved.
the connection type, because then we can make it positional.
Can we?
Of course.
Because I was thinking if we had a connection type, I would do something like this. That doesn't really fix the
Oh no,
problem.
if you keep it as like labeled mandatorily, then the idea doesn't work. But I was thinking on making it uh, positional, like the other initialize functions. Okay, now it's time. Go to the. You can go to main.ml, and let's replace the CLI type here that lives in there with the options type just for now. In the future, we're gonna receive CLI and have a conversion function, but this is not really required as of right now. Call the initialize function. You probably should do a let open in here, by the way.
Yeah, probably. Let open. Uh,
Compiler.types.op. Only compiler.types. That should be enough.
initialize Sakura. We
You need to pass address and port. So put anything.
actually I think it's like this, right? Address needs to be, let's just say localhost, I guess.
Yeah. And the port can be, I don't know, whatever. 34, 35.
Uh, sure.
Rename the let binding to options and pass that to the executor. Now let's go to the executor and fix there. Yeah, this is it. So now you need to use it, really. And you need to do some.
Oh yeah,
Oh,
this is optional, right?
yeah. Okay, let's actually try to aggregate all the Sakura related code because we need to identify if we need to error out this or not.
Hmm.
Yeah, preprocess one Karuta is not it. Yeah, I think it's only in the beginning. Can you go up? It's line 49 upwards. This is the place where we do the Sakura stuff. So, oh, that's easy. Line 43, we need to check if the Sakura files is empty.
If Sakura files is empty.
Yeah, because if it's empty and you have and you if it's empty, we do nothing. But if it's not empty and you haven't provided your Sakura config, then you're fucked. It's a match on a tuple. It's the same trick that we usually do. So you do match on Sakura files and match on Sakura, so we can do the matching together and use the or pattern. And there we go.
Match on Sakura files and match on
Together.
Sakura, right?
Yeah, yeah, but them together. No, not in there. Outside of this. Oh, actually, this works as well. Sorry, sorry, sorry. It works. It works. There works as well. I was thinking somewhere above, but that's fine.
Match
Sakura
Sakura
files.
files and
Sakura.
Sakura, I guess.
Yeah.
With, let's put this first actually. Let's flip these.
Yeah. So first we check um, if it's none and Marinho, are you there?
Yeah, if it's
Okay. If it's
none
none and empty,
and empty,
we do nothing. No, no, we're gonna. There will be more than one branch doing this, by the way. If it's some, but Sakura files is empty, we also do nothing.
if it's some
And
and
nothing.
empty, we also do
Yes.
nothing.
But if you have a none and something else, then it's an error.
This is a list, right?
Yeah.
This is
Then
an error.
you can put a fail
Uh,
with for now. And if you have a sum and something else, then we do whatever we were doing.
then we do root module, and we're not really using the address in the module
Yeah,
yet,
the
so I'm
type of
gonna.
line 46 is incorrect, by the way, because Sakura output is not a list. So you need to take care of that.
Actually, in this case, we do
The things down there.
basically let. I can basically just put this here, right? This goes
Yeah, yeah,
down
all of
there.
this code goes there. Maybe parentheses is gonna help. Not in there, but okay. Is that enough? That's not enough. So it should be in there. Well, you can also do that. The syntax apparently is
Wildcard not
incorrect.
expected. Do we need to put parentheses in this thing?
Aren't you missing pipes, man?
Pipes.
Yeah.
Oh yeah, I am. This goes here
You don't
and
need
this goes here.
parentheses. Okay, we need to fix type on line 45. So take a look on line 52, please. What is the type? What is the output type of preprocess function?
It's a result.
Okay, so you need to do one of those in line 45.
It's a result. Uh,
No, we need to create an empty output. Do you have a function for that?
I don't think we do.
So we need to create one. Empty output somewhere. We're gonna do the OK ourselves to make it an error type.
Okay.
Yeah, this is just gonna be OK at preprocessor.empty output, which doesn't
I'm
exist
pretty
yet.
sure. I'm pretty sure the output of the preprocessor is a list.
I don't think so. I
Or
think it's a
actually,
record.
it may be a. Is it a record? I don't think it
I
is
think it's a
actually.
record with a finger tree inside.
Let's look at it. Preprocessor.
Type output.
Output. It is a record, and there is a finger tree inside of it.
Yeah. So let's do an empty output, which
Let's.
probably means it should be a module, but I'm gonna do that later. We have merge, we have map on it, and now we have empty.
This has type output. And this needs to be dependencies.
Equals, not column. Dependency graph dot empty. I think we made this already. Yeah. And then the other one needs to be a batfinger tree dot empty. Perfect. Now we can go back where we were and do empty output in here. What's the next problem? Oh, you need to do a neighbor.ok, I think. Not that okay. Okay with, yeah. Okay, the next error appeared. Line 85. Progress.
We should probably make a proper error here, right?
Oh yeah, let's do that real quick style. So logger.error, simply error. And then the message should be something like no Sakura configuration found.
Sakura files without configuration.
Yeah. Exit one.
And then we need to exit one.
There you go. Great stuff. Very great stuff. Okay, 85. Let's go. Ooh.
The Sakura file name is used here as well.
I have the solution. But I don't like it. We can make the let star return a tuple. But what happens if you're not using Sakura? Yeah, the line 43 should return a tuple. That's for sure. The problem... Okay, counter proposal. I changed my mind. Line 88, let's return that in line 43. We're going to do the tuple trick again, but we can return this because we can have access to the file name ourselves.
You mean here?
Yeah. Maybe we don't even need Sakura output after that. Check where are we using Sakura output first. My bad. There. That's it?
Yeah.
Okay, we can return this tuple instead ourselves.
Sakura outputs dot dependencies and then okay.
That's easier, in my opinion. We can just return this from that function, from that let star. Because we have all the info.
Okay, so what are we grabbing then?
We are destructuring the output essentially, and dependencies and clauses, but we are putting the clauses in a singleton.
Okay.
Let's
I
do 45
guess
first. This is the hardest one. 45, I think it's faster.
45.
Yeah.
This one, right?
Yeah, so instead of... Oh, actually, we already kind of did. Empty output provides the tuple. Oh, no, but it doesn't provide the map. Let's do a let on the empty output to... Well, do we need an empty output, actually? We can just do this ourselves. Yeah. Okay, I think that's a better option. Let's remove this empty output stuff. And let's just say preprocessor.dependencygraph.empty, comma, batmap the .string.empty. Okay, that was easy. Now the hard one.
It's not Sakura files though, is it? This is the
Sakura output now. This entire thing is Sakura output now, which is the name of the binding up there.
okay. This entire thing is Sakura output, which means
Just replace there.
I'm
Bye.
gonna put this up there for now, just so we have a reference.
Sure. So I believe we can use the double pipe. So which I think it's bind. So we can just do 56. We can just literally just do the double pipe.
You mean here?
No. After we preprocess it, we do another line, like new line. Yes, that. And I don't remember the arguments anymore, but that should be bind operator thing.
Okay. Let's see.
Yeah, this is gonna give you an output. So just do a fun and do destructuring immediately.
Okay, so we need to grab
Dependencies and
the
clauses.
dependencies and the clauses, and this needs to be a semicolon.
Dependencies goes first.
No, this is a record.
No. I mean in the output tuple. And then we do the singleton thing that you already have in there. We need to grab the file name differently though. Oh, we already did line 54. Never mind.
Oh, no, okay, no, this is basically this, but then we don't need to qualify these because we're destructuring them, right?
Yeah. What's the? Oh, we need to put an OK on that. OK at. This is
Oh,
bind.
ah,
Perfect. Looking nice. Looking nice. The code actually morphed itself into aggregating the Sakura stuff in a single place, and I'm a huge fan of that. Okay, there is a problem in main.ml though. We should take a look on whatever is going on with that. Oh, you need to pass unit to it. We forgot. Because that's the only positional argument we have available. Initialize Sakura. This expression has types options of Sakura, but it was expected to be T. Oh, this is inside a record. We forgot. So put the record Sakura equals that. Oh, sum that, right? Because it's an optional. That's not gonna fly still. Sum. You
this thing
cannot do
is
that. Yeah, but there is a
Yeah.
function called option dot sum, I think, which you can do the at thing. Perfect. Okay, I think we did it. We have a way to communicate from the top level main.ml all the way down to the executor. This is using correct types, right? Because it should be a CLI type being converted to options, but we can do that later. That's completely postponable. And what we should do now is the entry point in abstract format.
We should commit this first, actually.
We should commit this first. What's going to be the name of the entry point? The name of the file?
That is a good question, actually. We need to
No,
figure that out.
no. Probably the name of the executable, which should be an option. Should be a CLI option and a project directive option.
Okay, let's commit this for now.
Yeah, let's commit this.
Actually, we're not using these, are we?
Yeah, we're not using it anymore.
This can go away then. Okay. So we changed main, we changed the executor, and we changed the compiler
Types.
types.
Yeah.
Let's commit. Um,
We should make another. We should extend immediately the options. Inside of the type T, you should have executable name.
add compiler options module. That's... Yeah, let's do this.
Oh, well,
And
okay.
then... Okay, so we need to know... The
Are we gonna
compiler
have a
does need to
default for
know...
that?
Not necessarily, right? Because if we decide to compile a library for some reason, we're not gonna have an entry point, are we?
Yeah, but that's a separate flag. Like what's going to be the artifact of the compilation? That's a kind of a separate thing. I'm talking about particularly about the name of the artifact at the moment.
Well, if you have a name, you're gonna have an artifact. If you don't have a name, you cannot have an artifact, so this
Yeah,
should be an option.
no, no, it should be an option, but should it be an option type or not? That's my question.
Well, it should be an option type because otherwise we would have to do a hack with an empty string as the flag to don't make an executable,
What's going
which
to
I
be the
don't like.
default name for the artifact?
Should it have a default name?
Well, if it shouldn't, then the name field in this record should not be optional. It's going to be just a
But it
string.
must be but it must be optional if we are going to allow people to compile libraries.
But the library must have a name.
But the library is not going to have an entry point, is what I'm getting at.
But again, you are talking about a separate concern. I agree with you that having or not having an entry point matters if you're compiling a library. However, that's not what I'm talking about. What I'm talking
Okay,
about is artifact name. In GCC, you can have an a.out if you don't provide a name. Are we going to have that?
uh, should we?
Well, I asked first.
I don't think we should actually, because here's the thing: there's a difference between the codes that we compile for the beam and the entry point that we're going to make, right? Because the entry point needs to be an executable, and the code that we compile for the beam is just bytecode files, like .beam files,
Yeah,
eventually.
no, but I'm talking about what's going to be the name in this case if you compile for an for executable. What's going to be the name of the entry point file? It's going to be what.beam.
Well, the executable is not going to be a .beam at all, actually.
Yeah, it's going to be a script, but sorry, it's going to be a script, but the script will have a name, right?
Yes.
We're discussing if we're going to have a default name for the artifact.
I don't think we should actually.
Okay, so we're not going to do the GCC thing. You always must provide a name for the artifact, regardless if it's a library or an executable. Again, that's a separate concern. It's orthogonal to what I'm talking about.
It's not really, because a library is not going to have an artifact. Or rather, it will have artifacts plural, but it's just the bin files, and the names of those are already predetermined. It doesn't matter what the user wants, it depends on what the names of the.
Ah, now I understand why you're making these connections, because I was thinking of .sos. But in the Beam, libraries is just a bunch of VM bytecode
Yeah.
scattered around multiple files. I see what you're saying now. Well, in that case, let's make an ADT. And if the tag is executable, you must have a name. If it's a library, you don't have to provide a name.
Um, sure, that's probably better than using a maybe, I guess. Um,
I would say artifact maybe, let type artifact or type mode. I don't know.
Artifact is fine.
So if you are an executable, you must have a name. And if you're a library, you're just a library. And you need to specify which artifact it is, right?
Yes.
Sure.
Well, we could say that the default is a library because you don't need to pass a specific flag for it, right? But for an executable, we need to know the name of the entry point. But that's a CLI concern. As far as the compiler options go, you have these options.
Yeah, so artifact equals artifact. No, not equals, sorry, column. We should make an initialize function for t now.
Let
Initialize.
initialize.
Sakura should be optional, and none should be the default. And you must pass the artifact.
Uh,
Don't forget unit.
and we need to pass unit. Very important. Sakura
And artifact.
artifact.
I think it's semicolon.
And it's semicolon.
Okay, now the main.ml should be. Yeah, we should change in main.ml first.
Main.ml.
Yeah, so let's change this to be. Let's call the initialize function. You pass the
We don't
Sakura
need
stuff.
this, do we? We can just say
No, you need to say the tilde Sakura probably.
Sakura colon.
And the artifact comes next, right? So we need. Let's do. What do you want to do? We should do executable, right? Because that's kind of what we're trying. That's the next step, implementing the entry point.
Yeah.
Let's call it main. I don't know. This is a big moment. What's going to be the canonical first executable for this language? Which name? Main is boring, so I changed my mind. What are your suggestions?
Uh, the name of the executable,
The canonical one, the OG.
the OG. Um, what about deal?
Sure, I like it. I like it.
Because the first thing you do in a
Deal
card
Karuta.
game is you deal the cards to the players, right?
Man, we should have. Now I'm changing. Now I want to have a default. Come on, man. Now I want to have a default so bad. Damn.
Okay, so what's the problem here?
We need to do semicolon underscore, but we're not gonna do that because we're gonna immediately implement the thing. Okay, so grab it, line 37, grab it, the artifact. We need it.
Okay.
Go all the way to the bottom of this function. Here, 101, we need the compiler that returns out of this thing.
We need the compiler that returns. Do we actually?
Of course, because this is where we have the forms and the shit, and the information of the module names and the file names to create the entry point.
We don't really need any of that. We just need, well, we do need the output, but we need it for a different reason actually. We need to know
The query.
the arity of the query. Yes. We
Yeah,
need to know the arity of the query.
but I think we are discarding the compiler along the way. We need to stop doing that. So go to compile one file, please.
Compile one file.
Yeah, this is probably discarding. Yeah, line 75. Remove. Just do. This is awesome. Just do bind OK, the OK function. Remove the lambda. Remove everything.
This is just bind. Okay.
Yeah. No, 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 no. The bind is already operator form. Okay. Now go down there where we were, and you need to destructure the compiler to get the externals, which is where what we were doing before. So in here, now we have a full compiler on this let. Destructure this mother flipper. Yeah, there it is. Uh,
Oh yeah,
ah,
actually,
I think I wait. Yeah, no, we have a problem because this cannot happen. This was how it was done before. You can do Control Z, undo all the way to the lambda.
mm,
The scoping of the type
actually,
variable. This the scoping of the
actually,
type
we
variable.
no, Lemos. We just need the externals because if we know, well, this needs to be another compiler option, I guess. Well, it's not really an option because it's mandatory, but we need to know. Okay, there's a bunch of modules here. Which one is supposed to be the entry point, right? Which one has the query that we want to actually call inside of start?
Yeah.
Um, so we don't really need to compile all externals files.
No, you can do Control Z, man. Regardless of what you think, do Control Z because we cannot do what I just said. I just
No, we can
forgot
just say this. We can just say this, and yeah, we do need to undo this. And the one up there
as
also
well.
needs to.
It needs to become what it was. That's why I said Control Z.
Okay. At. There
Yeah,
we go.
that needs to be undone. And I need to I should explain to you the reason why, actually. So the reason why is because actually let's fix the zero first because this is tripping me over. Go down there.
Ah,
Can
it's
you?
because this doesn't return. This doesn't return let underscore equals in unit. Actually, this
I
needs to
don't think I
return
don't. Yeah, I don't think this is gonna.
okay unit.
Yeah, sure. Go up there and compile one file. I should explain this to you because I did that offline, right? I did that after the session. So the reason that the okay, so let me explain lore and a little bit of the lore. Before we were doing the compiler in line 75, the full compiler, and we were doing the destructuring down there. Why did I have to change that? Because the scope of target on line 66 is only available in compile one file. So the type variable shit that we did the type Tetris last time of the existentials and the local abstract, The way that I fixed it was by acknowledging that it is true the compiler cannot know the type variable application outside of the scope of this function. That's why we couldn't make it compile. To fix that, I just said, okay, what do we need from this guy? Does it depend on a type variable? The answer was no, because externals is not parametric. But the
I
compiler
see.
C is. So I just did that and it fixed itself.
I see. That makes total sense.
Okay, now we can do whatever you were talking about.
Yeah, here. The executable actually needs two names. It needs the name of the executable, and it needs the name of the module where we're going to look for the query to call in the executable, basically. Uh,
Okay, this can be an anonymous record though.
oh yeah, it can actually. Um, Executable of root module, which is going to be a string, and um, well, name I guess is a string,
This is the name of what?
and this is supposed to be file name of the executable
Wait, I'm confused. Where is the crabbing coming?
from the root module. We're going to say, okay, there's a bunch of modules that we compiled, right? That's the externals map. Which module should we look for the query inside of? That's what the root module tells us. And the file name is, okay, what should be the name of the actual executable? And that's the deal that we did just now. Which means,
Wait, so the root
actually,
module you need to say which module the query is?
well, yes, because in general, we're going to compile a lot of modules, right?
Um, I don't know if I like that idea because that will allow people to have multiple queries and it's just gonna make reading a program like a newcomer coming from a company using Karuta. You don't know what is the entry point of the program because there are queries everywhere. And you're
Well,
gonna
the
have
entry
to ask the
point would,
DevOps people what is the root module we use for production.
well, no, you just look at the project definition, right? This would be defined there.
Not necessarily, because the CLI may override it. Well, that's okay. Let's go with this for now. But yeah, let's go with this for now. That's not a problem. This is very easy to change in the future anyway.
Okay, so file name is deal,
This is such a
and
hilarious good name.
which program
Let's
are we going to compile for our test? Because we're going to hard code
plus.
stuff for now, right? Plus. There we go. But that means the
Eh,
executor now.
wait, go back there. What if I want to
Not,
compile my Prolog file?
well, the prolog file is going to have its own name, right?
Yeah, but are we gonna do like? Oh, we're gonna ignore the extension then?
Well, we don't actually implement anything in the prolog standard library. We just allow you to use parentheses instead of square brackets.
No, okay, but we're gonna ignore the extension. If it's .krt or pl, we're not gonna care. Okay,
Yeah.
continue then. Okay, you
Okay,
said
so
we just need the
executor.
externals, right? You said.
We just need the externals because if the artifact is an executable, it's going to tell us, hey, here's the module where you should look for the query. So we go to the externals, we grab the module, we look at the query, and then we build the entry point using that.
Yeah, let's go down there into this function, the bottom of this function, because we need to change how compile all works. Um,
Do we?
yeah, because this returns unit.
Not anymore.
Oh, okay. Okay, so just okay, put that in a let binding there. So yeah, grab the name of that. Yeah, and then let's do a match on artifact. Because if it's a library, we should do nothing.
If it's a library.
Don't forget the pipe. You're forgetting the types today. The pipes.
Uh,
What's up with that?
well, that's because technically we don't need a pipe there. We need one here.
Yeah,
But
no.
yeah.
The first one, the OCaml people like to brag about it because in Haskell you do need. This is just OK unit, right? There's no entry points to be done, actually. But if you are an executable, however, then we have to do some shit.
Okay, let's do this for now. Okay, we need to grab the file name. And we need to grab the root
Root module.
module.
Perfect.
Okay, then that means, in fact,
We need to do a lookup immediately after, right?
yes, if the root module doesn't exist, then we have to handle that.
What the heck is the type of externals? We have to go to the types, compiler types, because I forgot.
Compiled modules. Wait, this returns a result. Okay, so
Yeah,
this needs to be a let star
yeah,
actually.
this is monadic. Okay, so it's an environment of comp times. I forgot what the environment is, but it's definitely a map. Let's suppose it is a
Yeah,
bet map string, just for the sake of the fun.
it's this.
Yeah, so I was right. Let's go. Match bet map string dot find find opt
Let open bet map dot string.
in
Uh, do I do let open? Actually, let's do let module. Um, map equals this in.
map
Then you can do map dot
find opt
find opt.
pass the file name. Oh, the root module, sorry, and
Pass the root
the compiled
module.
modules. So if it's
If
none, we should error. Fail
we
with
should
for now.
error.
No, we can do it directly. Logger dot simply error. What are we gonna report?
um, root module for the executable
Could not be found.
could not be found. And then we
Uh,
just exit one.
yeah, and then if it's a sum, then poggers.
We do actually need to do a lookup on this because we need to find um,
The query.
the query.
And how do you plan on doing that?
Well, we know the query will always have an empty name. The issue is we don't know the arity necessarily. Um, can
We
we
need to
fix that
destructure this
somehow?
first because this has location. So open curly braces content equals, and that we're gonna use that. So this is what module, right? This is the root module. Yeah, root. Let's know. Root is better because module is taken. And the location. Grab the location as well. Yeah. So now the how do we gonna figure that out though? What is the arity of the thing?
Uh, okay, let me think for a second. Do we... Let's go to the type of this thing actually. Hello, Mageta. Hello,
Hello,
Tevo.
I have questions for you.
Go for it.
So, I just explained to Tevo like what I've been doing, and I
We are
think we'll
recording, by
be
the way, just for you to know.
yeah, that's fine. I just want to discuss some parts of the design. So, namely, we're going to have branches.
Yeah.
However, our branches need to have. So I was thinking of the following. For you to have the state of the world, like knowledge of the state of the world, and recompose the database, you need to have a version, a specific snapshot version of the multi-group you're looking at. Uh, the multi-group is the database object, okay?
Yeah.
So, and that contains all the relations and the tuples, attributes, etc. Now, the problem I see is the following. Imagine you have two branches, okay? Each branch will be completely isolated and they will be isomorphic with what is on the multigroup. But then you only have one multigroup per branch, and that's bad. So it is reasonable to handle multigroups as parts of namespace, and then you guys are able to access triplet for every named for every relation, or fourthlet, I guess, for attributes. For example, I have a relation user on the database on the multigroup coffee shop, and you have the schema for, I don't know. Uh,
Ah,
uh,
okay, that's why having one multi-group is bad, because there's schemas. Fuck.
yeah, well, not only schemas. Schemas are collections inside of a multigroup, right? Which we don't have yet, by the way. I mean, they're just part of the name of the relation, but that's easy to pull off. Uh, the danger here is the following. Imagine if you want to do a modification, like any kind of transaction or thing that requires you to do multi-group queries. Now, Postgres does a hacky job at solving this. So do most the other databases, which is a foreign data wrapper, right? So you can actually refer to things of other databases, but you need to make a wrapper to them. I think that's silly. I don't see a reason why you would not treat
Oh wait, so
the
the reason
database.
this you're talking about this is because having more than one multi-group is because you're doing a query in multiple databases.
Yes, I was thinking if it's worth allowing, and I think it is. Like if it's worth allowing you to create a
How is the
query that,
versioning system with multiple databases?
well,
Well, each
you
database, like in order to run a query, you have to choose the commit, quote unquote, right?
yes,
You
and
have
then the
you just
commit hold
yeah,
like
you
the
just
branch, the commit, right, holds the information for all multigroups.
But
I
what
think
if you
that's what
don't
money.
own some of them?
well, actually, the way the Atomic does it is slightly different. You can run a query using multiple databases, but each database is a snapshot at a particular transaction,
Yeah,
basically.
that makes more sense to me.
But that is what I said.
No, but you said that it's gonna be a commit for every one in a single commit, right?
You use database one and database two. I'm gonna say database because it's easier than multi-group,
Yeah,
but
yeah,
you
yeah.
use one. Each of them produced a new hash. That becomes the hash of the head of the branch that you are.
Okay, but what if I am in a branch and I'm using database one, and during the implementation process I decide that I want to use database two? Like, what if I don't check out both from the beginning?
Wait, repeat the flow, please.
My maybe this is a silly question, but I'm gonna ask it anyway.
No, maybe
So,
not.
my question is, what if I start like I'm writing some code, some backend code, and I decide to take a snapshot of the world to do some stuff, right?
Mhm.
And then in the middle of the process of doing that, like I'm writing more code, and then I decide to grab the snapshot of database two. I don't have so like now I have two snapshots. I have two commit hashes
Oh,
of
I see.
two
So you're
separate
saying,
databases.
how how does it deal with expanding the scope? You're saying?
Yes, like how exactly? Scope is a great way to see it, in my opinion.
Well, hmm,
Because if you snapshot both in the beginning, then it's fine. Then I
I
understand what you're
guess
saying.
I guess the usage would basically generate a new version of the branch, I suppose, right?
Oh, so that would
That's
be a
like
new checkout.
that's more like a rebase, I think, or a
Yes,
merge in this case. You're bringing the changes from something else to work on your tree,
yes,
on your branch.
yes. I tend to agree.
Okay, this is strange. I think if it's is it worth doing like I think the only difference really from what I was thinking with what Marinho said on the atomic thing is that the transactions are objects on the atomic, right?
They
Uh,
are.
I don't want to make them objects because I think that's an implementation detail. But you can still have an object pointing to the commit, which is a transaction in a sense, but it is the user facing transaction. Or maybe that is the same abstraction, I think.
Marine, there's a problem with what you're doing.
What's the problem?
Did you just enhance the compiled module type to carry an optional query?
I did.
So what happens if the Sakura people try to have a query? The compiler
That
types would allow that to
that's
happen, right?
yeah. We should. Uh, no, actually, that's a
Actually,
compiled module. Um, we don't allow that because you can't have a query at the top level of a Sakura module. We check that in the preprocessor, don't we?
I have no idea.
Well, we should if we're not doing it.
Okay, that's because I was about to say that it feels to me the same situation as the mutability thing. The reason that we introduced a type variable was because we don't want to allow the Karuta compiler to even attempt to do bullshit. And I was about to say the same thing right now with the query, but with the opposite situation, right? If what if the Sakura compiler tries to put a query?
Well, the Sakura compiler should not have any predicates at all at the top level. I'm pretty sure we're doing a check for that already.
Well, let's go to the preprocessor and check that out. Anyway, Mageta, yeah, I think scoping is a problem with your idea. I don't know how to
Uh,
solve it though.
in
Well,
the,
your proposal sounds fine to me. If you
like
merge the scope, we check out another
what
branch.
do brands want? That's what I want to know. Like what do you think would be more valuable to represent? They will rephrased the question as should branches contain multigroups or multigroup contain branches? I think that's a better way to frame it.
Wait, let me reread that again. Should branches contain multigroups or multigroups contain branches? My intuition points to the former, uh, but I don't know how would the latter work really.
Yeah, we're already doing it, Lemus.
Okay, so then never mind what I said. Well, we are not erroring out though. We are just ignoring on the filter. That's kind of
No, we
different.
are actually.
Oh, okay. So then never mind. Continue doing what you're doing. Anyway, so what would multi-groups contain branches look like, Mageta?
Uh, multi-groups, they would have objects inside of them that contain snapshots of work, I suppose, that you are
Oh,
performing.
it's I see.
I think we came up with the idea once of making a meta multi-group that contains all of this information. Do you recall that, Tim?
That would be the Sakura multi-group, but we have to think about what we're going to do with that if we go with the former approach.
Man, the hardest part of this thing is designing. I
Yeah,
don't
I
think it's
think
even.
I think to not bottleneck the entire thing, I think we should just say that version 1, if you want to handle multiple databases, you have to grab their snapshots on the spot, which is less flexible and annoying, but I think to not block the entire creative process, because there's so many more things to do, and I don't know, maybe tomorrow Mageto's gonna have an epiphany and solve the problem, but maybe not tomorrow. Marinho, what are you looking for? How can I help you?
I'm looking for the places where we are compiling. I think this is it though, where we are compiling.
This should be the only place.
Yeah, this is where we compile a query. Right, because we have the read the parser. It spits out parser clauses. The preprocessor turns those into regular clauses, and then the compiler turns that into bean code and enforces the semantics.
Wait a
So
moment. What happens if you have a nested query?
that's allowed. But the way we set up the root module option, you can't actually call them. So maybe we should do something about that.
Yeah, but I think that is allowed because line 16, right? Line 16 is passing the step onwards, which means that compile clause is going to be called again. Which means I think we should not allow that because then that's gonna. Is that a problem?
Well, it's dead code, but
Okay,
hmm.
let's go back to the other call table. Let's
We
do something.
keep we push the
Well, we have.
directives all the way to the top, right, Marinho?
Sorry.
We push all the directives back to the top of the file, right?
We push them to the top of the file, yes.
I think we should change that. I think we should put the query on the top, and then if on line 22 we check if we already have seen a query, and if we have, we should error out, because this means that you're trying to put either another query on the top level or it's a nested query.
That's not how that works. If you try to put more than one query in the top level, they'll just be consolidated into a single query,
Is that
logically.
how the parser works?
That's how the preprocessor works.
I thought we
Like,
made it with commas, not if they are hanging around.
actually, I'm not sure. Actually, I may be
I
misremembering.
have no recollection of what you said. It would be cool if we allow that, but I don't think that's the case. Yeah, the preprocessor cannot tell because the preprocessor already receives the consolidation as query conjunctions. So it's the parser responsibility to group them up if that happens.
I guess technically we can try that out. Go to plus for a second, and we say there are two queries. Then what happens?
Yeah, I think
Uh,
this is not gonna fly.
we need to make
Put
this.
a fail
Let
with
us.
there. Oh, that also works, but then it's not gonna allow us to compile because of the we put underscores on those on those things. Yeah, that's a little annoying of OCaml. Tiny bit annoying.
Technically, we're not using any of these. So, there we go. Dune, Zach,
If what you said
Karuta.
happens, I'm even happier because that means it's an unreachable. What I said.
Examples plus
That's bad.
process
So it
terminated. Oh,
compiled.
it's because we're importing minus. We should.
I don't think that was related at all. Yeah, already defined. We are not checking if you have duplicated queries because we are
This is
assuming
failed to. This is failed to eval. So actually, this is failing
on the beam.
on the beam.
Yeah, we are allowing this to happen, but it doesn't make sense. Well, it's not that it doesn't make sense. It's not being done properly, which means that we are trying to do a redefinition, which is what the beam is complaining. So what I
Yeah,
think.
I don't think we are checking that for the query case, unfortunately.
Okay, but let's assume that we are because I think it's cool. My idea still works because here's the pitch. Uh, it's not in here. It's in Karuta.ml. Here's my pitch. If let's suppose what you said is true, that if you have multiple queries, they are already being agglutinated in a single query conjunction, okay? If that's the case, you should have only one query on the top. Agree?
Yes, we should have only one query.
Okay.
Well, technically we can, regardless of if we're doing that or not, we can do the check here because we're going to need to, like when we see a query, we need to save that to the compiled module so that we know the name and arity of the query, right?
Exactly. No, exactly. But here, let me finish the pitch. So then my idea is the follow. We go to the preprocessor where we are sorting the directives. We make the query priority to be on the top. So when we go to line 22, it's going to be none in the compiler, and then we put it. And then we do a, we before compiling, we check if somebody nested is trying to do it, because that's going to happen on line 16 anyway. And if they do, we just error.
That doesn't work for two reasons actually. The first reason is that right now we still don't have proper order independent compilation. So if you try to compile the queries before the nested modules, that's just not gonna work if we reference anything from those modules. And it's also, I'm not sure if that will work or not with other predicates. It should, I think, but not with things that are in nested modules. So that's one point. The other point is we would need to keep track of the query globally to do what you're saying, and we're not doing that.
Keep track of the query globally.
Because right now you can have a query per module,
Yes.
which means if you have nested modules, each of those nested modules can have a query of its own,
Yeah, but I want to forbid that.
which requires us to keep track of the queries globally, because otherwise, how do we know if there's already a query somewhere else?
Okay. Uh, doesn't matter. What you said, I think, doesn't apply because we are specifying the root module anyway. So if you have queries in other places of other modules, we don't care.
No, not in other modules, in a nested module inside of the root module. Like you could have a query at the top level and then another query in a nested module.
But I'm just said that I want to forbid queries on nested.
And how do you enforce that?
Yeah, that's what I said. So let's backtrack. So if we do what I said, okay, one problem at a time. The first problem, which is the order independent compilation thing, I think you were right. However, we can do a trick to get around that, because when we encounter the query on the top, we can just save its name and arity and not compile it at all. Maybe the preprocessor can do that duty actually. Anyway, and then we can get around the ordered dependent compilation thing, because we're gonna keep the query on the bottom and compile the modules first, but we already saved that we know what's supposed to be the query on the top level of this file. And then the second thing, which is the nesting, my idea of doing the checking for the option field in the compiler is precisely to disallow that to happen. That's why I wanted to put the query on the top, on the first idea, on the first version of the idea, because if the top level query is on the top, we can check if it's none, and if it's none, we save it. And everybody onwards trying to have queries nested, we're gonna have the sum match. Or doing the find, if we do the match, it's going to be sum, and then we can, if you want to allow that not to be an error, that's fine, but then we just ignore it because you only care about the one on the top level.
Hmm. I'm not sure that I like this because this makes the language less uniform.
I don't like it, but I don't see a better way to do it, really.
Well, we could change how we specify the root module
And I think I'm
to.
changing my mind about your idea. Sorry to interrupt you, but I think I'm changing my mind as we talk. I'm changing my mind about liking the idea of allowing the conjunction to be separate, because that would confuse me in terms of the bindings. Because if I have two question marks and they are using the same label, they are connected even though one is in line 1 and the other one is in line 1000.
That's fair enough. We're not handling that right now. We have to deal with that somehow. If we're going to check,
No, but
regardless, because we need
I
to.
don't know if I want that at all in the
No,
future.
no, no. I mean, that's not implemented. Right now, we just, okay, if you see two queries, you try to compile both of them, and then you have a name collision on the beam.
Exactly. Like and what is my reasoning is because if you make automatically they conjunct, then the bindings unify and they are very distant from each other. And I think
That's
that's
fine.
bad
That's
programmer experience.
non-local, which means, yeah, this is a good argument. I agree, we should not do that. We should have one query per module at most.
Yeah. Okay, now sorry to interrupt you. Go on.
Uh, yeah, no, I was just saying, I don't like the idea of allowing queries only on the top level because that makes the language less uniform. So there is actually another option of what we can do, is just to say, okay, when you specify the root module, you can actually put a qualified quote unquote module, and then you can do a nested lookup and you can use the queries inside of a nested module if you want to.
Uh, okay, so your idea is that you specify the root module. It can be if you specify a single name, it's the top level module. But if you use columns and you start putting more qualifiers, you're gonna try to do a nested lookup.
Yeah, basically.
That kind of means that we have to parse the root module CLI now.
Not really. We can just split on column.
Okay, let's do it. Let's do that first. Uh,
Okay.
well, actually, no. Let's do this first because this is already on the screen. So line 37, let's save the query.
37. This is in the compiler though. I'm pretty sure. Yeah, we have a state, we have externals, we have imports, header, output, file name. Yeah, I think we need to add the query here as well, actually.
You changed it in the compiled module, right?
Yes, because the compiled module is what gets saved to the externals at the end, right?
Yeah, it's mutually recursive, I remember. I don't like that you have to save that in two places though. That kind of bothers me.
Well, it's not in two places because
Yeah, they are
when you're
passing the
in the
baton.
middle,
I understand.
because when you're in the middle of the compilation process for one module, you have this, right? When you
Yes.
finish, you emit the code and then you strip out all of the data that's in here except
Externals probably.
for the env actually, and you save that to externals.
Okay, so we need to change the step function, and we need to save the query in the type T. That's what you're saying.
I'm pretty sure we do. I'm pretty sure we do.
Make a type alias for it so we can make sure they are the same type.
There's already one actually. We
That's a
can just say the
field, not an
predicate.
alias.
No, it's this type.
Yeah, I was about to propose an alias for that. But I think that's simple enough that we can just copy paste it and make sure they are the same.
State T.
Yeah, now we need to go to the step function and do the pass of the baton, I think. I think it's on
Query.
step that we do that, right?
I'm pretty sure it is. Actually, is it? Well, let's run this again.
Yeah, this is gonna work on initialization functions, 100%.
This is 159.
Yeah, so now we need to put a none in here because initialize nested is for nesting. Initially there's no query, so this is just none.
Okay. Oops. Query equals none.
Yeah, but go to the step function. Let's see where we need to see where we are augmenting the environment. No, not in here. Step
Uh,
function is where you were. There we go. So where are we doing? Yes, It is in there, 200. We need to do something kind of similar. You see line 202? That's the money there.
202.
Yeah, this is where we are
Module.
grabbing the env and immediately passing that to the thing. I think we need to change the env first before doing the add. What do you think?
Compiler.env.
Yeah,
Compiler.env.
which is compiled module, right? And compiled module is where the other query field now lives.
Wait, compiler.env is a compiled module already.
Yeah,
Is that correct?
yeah, of course. We are saving ourselves, buddy.
Wait a second. So actually, we may not need that because if env is already a compiled module, there's already a query here.
But we don't know that yet. That's kind of the problem. We can only augment the env, the compiled module in the env field after we are done with ourselves because we just discovered our query maybe.
Well, when you are compiling things, right? As you find the definitions, you add them to env, don't you?
Well, we are not doing that for the query.
Well, we need to do that starting now, basically. So since we have the query here already, we actually don't need this, in fact.
Yeah, we remove down there as well. But then again, how are we gonna add? Okay, let's go to the Karuta.ml and do it then. If you said we can, I believe you, Marie. Okay, so see
Okay.
line 9, you have the compiler env in there.
Yeah, we do. We have the whole compiler which has the env inside of it. Basically, if we look at declarations here, right, for a second, when you compile a multi, inside of here, we change the env here, you see? So what we need to do actually is we're changing the output because we are
Compiling the query.
Compiling the query, but we also need to change
The env.
the env. Env equals. Are we parameting that anywhere? I don't think
No,
we are, right?
no, we're not. The env is only in line 9, but it's hidden behind the compiler label, yes.
Query equals sum, and actually, yeah, let's do this first, and then we implement the check to make sure we don't have more than one. That's
Yes.
better.
You need to create a predicate name now, which has a name and an arity, I believe.
We do, and this is basically, yeah, this is basically a name and an arity, which we do have, in fact, arity.
There you go. Like this feels like we are making the right decisions. We just decided that we have to save the query for the module, and that was like a 2-line change. That feels that we are doing a good job.
Yeah.
Okay, so now we have to impede you to have more than one query. Who should do that? The preprocessor, right?
No, actually, we can do this in where we just changed, in fact, because since we're setting the query for this module to be the query that we just found, if we just check if there's a query already, then we can fail gracefully.
Let's do that before, yeah, there, immediately there.
Before
So,
anything,
yeah,
right?
if
We just say if.
option.isSum.
Actually, oops. Actually, yeah. Option isSum.
Compiler.env.query. Then we just
Then we need to do
logger.
something.
Yeah. Logger.error probably. We should have a location at this moment.
We should have a location, yes. I'm not sure where it is though.
Clause.lock. And the error should be
A module can have at most one query.
Yeah, but this is bad. I have a proposal. Let's put location in the query
Maybe you should
field.
add the location. Yeah, that's
Yeah,
fair enough.
so it should be option of a predicate name with location. Yeah, put in the middle location with location in there. Yeah, now that's gonna break the types, which is expected. Let's fix this first. So this should be some record content equals that. And that also works. And the location comes after. Clause.lock. At. Or parentheses, right? Because
Yeah,
parentheses,
because
parentheses. Because constructors are not functions in this language for whatever reason.
for whatever
Um,
reason, and now, yeah, this
he
is
cannot
not
infer the type
inferring the
properly.
type anymore.
So can you do predicate name dot name maybe? Like because predicate name is a module, right? I think.
No, predicate name is actually just a type inside of types.
Can you make a let
Uh,
inside of the like?
I don't think that works.
That doesn't work.
Types, predicate. Let's just go here. Is an ASC.clause.head.
Yeah, this was done on purpose because then we can reutilize the same types everywhere, and uh, they are the same. Okay.
There.
I don't understand why OCaml cannot infer that. But okay. Okay, let's continue the error message. Line
I think
24.
it's because the inference is done bottom up from the leaves of the expression tree up to the root.
Yeah, but if that was the case, it should know that, oh, what is the type? Okay, it's bottom up. That's the reason. Okay, never mind, never mind, never mind. You're right. Okay, line 24. A module can have at most one query, and then we have to log another thing again.
Yeah, let's actually change this because since we have the location in there already, we're going to need to destructure it, right?
Ah, yeah,
So
duh.
we may as well just do a match
Yeah,
match
now I think it's worth it.
compiler.name.query with
So if
um,
it's
if
none,
it's
no,
none,
that's
we
the happy
just
case.
do
That's
nothing.
everything else. The none should be on the bottom, the none, because the none is everything else. Just gonna wrap it in parentheses.
It doesn't matter the order here actually.
What? Ah, you are doing like something that
This
just
is
does
a
the effect.
yeah.
Ah, okay, that's okay. So some content equals. Oh, no, content we don't care, just the location actually. Lock semicolon underscore.
Lock. Um, let's actually give it another name because oh no, we have clause.lock. Okay, never mind then.
Semicolon
Underscore.
underscore that.
Um, okay, let's put parentheses here just so we don't go crazy.
Okay, we need another logger error using the lock. So lock and first query defined it here.
Lock.
Semicolon. It did bullshit. The formatting
Yeah,
did
this is
bullshit. And then exit one.
exit one.
There we go. It did bullshit
What?
again.
I need to put a parenthesis around the entire match, don't I?
Okay, that's sad. But well, I cannot really complain because that would mean that is space sensitive, and I don't like that. Okay, so that's it. So now we can have the thing. So now let's go back to the executor and finish our stuff. 15
Let's go back
minutes
to the
left.
executor.
There we go.
Okay. Okay, so that means if we find the compiled module, we can actually grab the
Content equals compiled module. Oh, sorry. Yeah, no, that's it. Compiled module.
content equals, and we don't really care about the location. We need a query, right? Actually,
Yeah, I think so.
do we need a location?
Probably not. But that's just that's not the structure that there. That's gonna be too messy. You can just do query.content in a let binding or whatever. Just do semicolon underscore and call it a day.
This pattern should not be a record. It should be a lookup. Ah, right, because actually this could be a.
A signature.
This can be a signature. Yes.
So we need to actually error that out. So let's do the pattern matching of the error first. So just put
Oops.
signature tag on it. Underscore.
Okay, let's do some. Um,
Signature underscore. Grab the location. And then another loggy thingy. So logger.error. And the error should be
um,
something like uh,
expected a module um, as the entry point,
but found a
but
signature.
found a signature.
Exit one. And now put module before the curly brace there. There we go. Unused variable. Let's go. So we have the
Okay,
query
so if
now.
we have the query and um, let um, name arity. You just name an arity, right?
Yeah, equals query.content. Now, yes.
An attempt. This is not an attempt. It's an
Oh, it's an
option,
option.
actually. Oh, right, because we need to check if we actually have a query.
That's
That's
another
true.
error. So copy paste this line. Do the equals query equals to none. And if that's grab the location. No, don't forget, grab the location. Module does not have a
Actually,
query.
I'm not sure if this location is that helpful, but okay. Um,
Actually, we should grab the location of. No, no, this is correct. Does not have a query. Yes. And now we know that now do query equals okay some query. Wow, the shadowing is insane in that one, but okay.
this.
This is correct. Yes, it's a head location. This is not just the inference is fucked, essentially. For probably the same reason that you were explaining to me before. Okay, so now we have to do beam stuff, don't we?
We kind of do. We kind of do, but we kind of don't because we need an actual executable file, and I'm pretty sure .beam files, which is the only thing we know how to emit right now, they cannot be executable because they contain. Oh, they actually we emit abstract form, and then that gets turned into .beam
The
by the
logging the
Erlang
compiler
compiler.
themselves.
But then a .beam file is not really an executable because it just contains beam bytecode. It doesn't know anything about where to start running. Huh. Okay, I think now is the time where we need to go into the Erlang documentation and figure out how to make an executable, I guess. Because
Okay,
I'm
so
pretty sure that changed a little bit recently.
how to make an executable in Erlang. E-scripts. Man, but that's gonna suck, no? Because, well, I guess it's gonna be a tiny script, so maybe it's fine. I already have it. It's just 3 lines. You just make an e-script.
Okay.
So, um, yeah, here are the lines. But there is a problem. It's using the shebang nonsense, which means that it's not Nix compatible. Because we don't have user./local/beam things. However,
No, but we have user slash. Actually, it's beam slash user slash env, right?
yes, yes. Probably the silver bullet is to make an environment variable that the Nix flake is gonna emit of where is the eScript thing, and then we read the environment variable in here or something like that. That's probably the safest way to do it.
Read the environment variable. What environment variable?
Like the way my brain immediately thought, okay, we make a shell hook in the Nix flake that will find your eScript executable in the Nix store, and then in the shell hook we emit an environment variable to save that path.
That doesn't work if you want to run your script outside of a Nix environment.
Well, but the solution for that is easy. You just make a CLI option to provide the path to your eScript.
Or you can use user slash beam slash env.
No, but that's gonna fuck us over in development
Why?
because in Nix OS, things don't things are not done in user/beam. For example, if you want to do a bash script, you do something else. You don't do that. Let me
Wait,
grab
so
it.
Nix. Wait, so Nix doesn't actually have the basic.
No, it does. It's
Uh,
just not in user bean.
like Geeks actually gives you this by default, and it's literally the only thing here, just so you can run shell scripts written like portably.
Wait, maybe
You're
it
telling
is
me
you.
that
Wait there. Maybe it is in Nix as well, and I just because I already got this problem at work at least twice. That people told me to run a script and I couldn't run it because I was running in NixOS, and I had to change the shebang path. But maybe the Erlang folks are actually secret Nix enthusiasts and they know that. So they already decided to put in the docs the correct one.
no, this is not the correct one, I don't think.
Oh, that's local. Then that's different. Then I think we are done.
No, we can like literally just you know, just use a different shebang. I'm pretty sure I do that actually in the where is it? Where is it?
Be
In
careful to not
the
show work stuff.
it's not work stuff. It's in zero in the examples.
No, so let's copy that because that worked for me.
I updated. I did a kick spool earlier today,
Let's just search for
and it
zero on Google. Let me do that. Zero.
actually I can do this. Zero. Oh, it finished. Okay, so if you go to cards and go to dealer.earl, you see?
Oh, okay. So and this works on my machine, so we're good. Never mind my anxiety.
I would be very surprised if NixOS didn't have this, because then running random scripts would be very painful.
Oh, let me find that out for you. User bean. Wait. Okay, so can I go to user? Wait a moment. Uh, do I have a user? Come on. Like I can I don't have like I'm trying to do cd user. Is there slash
Ah, no.
user?
Oh yeah, it needs to be slash user. You don't
Yeah,
have that.
I don't. That's what I'm
That's
telling you.
ac- that's actually kind of surprising.
Oh no, wait. Now that worked. So now beam, yes, and there is an env here.
Well,
Yeah,
there you
no,
go.
there you go. Okay. Anyway, let's make a. This can be fast, man. We can have an executable in 10 minutes. Let's just do the following. Make a file called escript.ml.
escripts.ml.
Maybe inside the beam. Maybe inside beam. I think that's better, maybe.
Uh,
And
here,
we're gonna
right?
have and we're gonna have a single function in this guy called emit, and it should receive whatever arguments we need to make this happen.
Well, we need the name and arity of the query, basically.
That's it? Are you sure? Are we
Well,
just supposed
yes.
to have the start stuff?
Well, that's we can just assume that exists because that's part of the Karuta runtime.
No, but we have to pass it though. We have to pass the config stuff.
Oh yeah, that is true. Then yeah, we need the configuration the for the Sakura connection.
Okay, so it needs to receive.
Plus plus this, yeah.
Yeah, so let's write that. So emit receives a predicate name, which we predicate name. So just do this structuring here to grab the name and the arity.
Name, arity, and
And we
this
need to
is we can't make the beam depend on the compiler, can we?
well, this module is isolated, so it can because this is not going to import beam stuff.
I'm not sure that that works because this will be inside of the logical beam module, regardless, and the compiler depends on that for the code generation.
Well, if that's true, then we cannot reuse the type in here. We're going to have to receive like loose things.
Let me double check that because
Types.
AST. Oh yeah, AST is actually a separate module
Oh, that is
completely.
handy.
It's almost
Clause.
like we know what we're doing.
It's almost, man. Almost. Never mind the gigantic refactorings from time to time. Predicate name.
Actually, in there it's called something else.
Head.
It's called head. Yeah.
And I need to receive the Sakura stuff, which lives in the compiler because it's an option.
Okay, maybe then that's an argument to move it somewhere else because we're gonna need it here. Actually, do we? Because we need to turn the Sakura options into an Erlang map at some point. It could be before this.
I don't like the idea of doing that before because that puts this is not responsibility of the executor at all. The executor essentially wires the people. In my opinion, eScript should be doing the Erlang conversions.
Okay, that's fair enough.
So we need the type. We need the option Sakura shit stuff. Well, let's try it. Maybe it works. Who knows? Compiler.types.options.t.
Dot .t. Do we take a dot .t?
No, the dot Sakura actually. Equals to unit. I don't know. See if this compiles.
Yeah,
Nope.
dependency cycle.
Nope. Counter
because if we
counter argument.
change
Counter argument. Let's put the Sakura options inside of the Sakura.ml.
Sakura.ml,
Oh, database.types actually. Database types. Even better.
database types. Does that work?
Yeah.
If we depend on database types depends on the compiler types, I'm pretty sure. Oh, it doesn't.
Yeah.
Okay, that works actually.
Okay, so copy paste the. Yeah, we need to make an options module there though. So grab the options from the types from the original thing, and we need to copy paste it first, and then let's remove the Sakura stuff. Like copy this entire module's options thing.
Uh, Actually, we can just copy this, no?
Yeah, no, it's just because it's easier to. Well, to me, it's usually easier to paste the entire like module struct block. Paste it in here.
Uh,
Don't forget the end keyword. Go back to the
okay.
original options and put
This
T
can be a
here.
this
Yeah.
can be a T. This can be an initialize, and this is T.
Go back to the original one and let's refactor that. Quick styles. So line 294 to 97 die. Bye. And here comes the real question. Can we depend on database types? In here. That's a very different question. The watcher is fucked, by the way.
Oh yeah, we need to go to the Beam script
Change
and
that to T.
let's make this unit for now.
Now, of course,
Mm,
unused, unused, unused. Does that work?
Not
No.
really. Dependency cycle between Beam script, compiler declaration, database directive, and Beam script. Oh, actually, there are two cycles.
How
There are a
fun.
bunch of cycles, actually.
How fun. I wonder why. Okay, so the first one is database directive using compiler types for whatever reason. And that is using the lookup. Man, that's very hard to read. Holy damn. Um,
I'm pretty sure all of those types are created from these, though, because that's what literally what you just changed.
all types are created from what?
All of the cycles involve these options here. I'm pretty sure.
Okay, so what's the drill? Let's make an options folder and have Sakura and Karuta there. Like, what are we gonna do?
Does that work? Does that work?
We cannot be inside of the compiler namespace at all. And we just discovered that being in the database namespace also doesn't work.
Hmm. Can't we? Can't we move the entry point script somewhere else? Like instead of being beam.escript, we do, I don't know,
Entry
compiler.entry
points.ml?
point or something.
Sure. We can move the eScript. Well, the reason that I don't like this is because that's gonna kind of conflate because we're gonna be emitting Erlang, and that's gonna be in the middle of the compiler, which is full Karuta all the way.
But the compiler knows how to, well, it calls into the beam serialization primitives.
Exactly. Which lives in the beam. It just references it.
Hmm. Yeah, that's not a great option either, is it?
Um,
I mean, we can make
dot
one
raw.
called entrypoint.ml, I guess.
I guess that's gonna have to be as of right now. Like I still don't like it because this should be inside under the Beam umbrella, but I can deal with that later. Your watch mode is probably fucked to oblivion.
Let's see, what's the problem? Database, compiler, database, and then signature, database, compiler, signature.
I think the compiler.types cannot depend on database.
I think that's the case as well. Although uh, we don't have the problem anymore of okay, the beam depending on the compiler, which is the problem we were having earlier.
Yeah.
Sakura.
Are you gonna undo the things then?
I'm going to undo the things, yes.
That's very sad. It's very sad.
Yeah, this can go like this, and then compiler types can go like this. And then we can restart the watcher, and we don't have a cycle anymore.
Yeah, it's just a bunch of unused. Okay, let's do this real quick style. So my understanding is that we can make this as simple and like naive as possible. We just need to write into a file. We know how to do this. Go to url.ml.
You know what? We actually need something else. We need the persist function, don't we?
Oh, okay, so the persist function, that is
Because
true.
that's what we use to write to the disk to files, right?
Yeah, but I kind of thought we would do an exception on the entry point. But yeah, I think it makes sense. We need
I
to
mean,
receive a module then.
we already have the function. No, we can just receive the persist t,
No,
right?
okay, that works. We don't have the dependency on the well, we don't have the cycle dependency on the compiler.
But this takes forms, and we just want to dump a string in there.
Doesn't
Never
matter.
mind then.
No, it's just a time for a new member on the persist module. Just add a new
No,
something
no,
else.
no. Uh, well, this takes a form.t.
Man, we're gonna
I
write
guess.
Erlang, right?
Yes, we are.
So T is not gonna help us. This is abstract form. Go back. My proposal is to put a new member in the persist module.
Okay.
Entry point.
Raw.
Raw, even better. String to unit.
It needs two strings actually because this first string is the file name.
No, that's true. That is it. So now we need to receive a persist.raw in the thing.
We do entry point.
Compiler.types.persist.raw.
Let's open compiler.types.
It's just open.
Right, because this is
Top level.
a top level.
Raw.
Persist.raw, and this actually can go away.
Okay, there is a slight problem. We need to pass persist.raw to the executor.
There's an error in the executor, and that's just an unusable variable. Okay.
Unused. You heard what I said?
Yeah, we need to pass that here as well. Where are we receiving? Where are we passing the persist though? I don't remember. It's been a while.
There, 38.
Yeah, this
This should be a module.
should be a module. This should totally be a module.
Which means that persist needs to be a functor now. Right?
persist needs to be. Does it need to be a functor?
Yeah, because
This has two types. This can
exactly.
just be a record, I guess.
Sure, that works for me as well.
Uh,
Both. No,
oops,
no, no,
not
no.
ret, raw.
Yeah, so you
Like
receive
this, you see?
in the executor you receive both.
Yeah, see, it's funny.
Yeah, but that's hilarious, man. That's very funny. That's not gonna fly though. The executor now needs to change where it initializes the crap out of it. Uh, that's a little bit of a
Just,
lazy work. I don't like that. Because the names matter, and we are converting one name to a worse name.
it's because theoretically I should be able to do this. Actually, let's not do that. Let's keep this as it is, but then let's change the existing uses to have persist.structured. I think that's more readable at a glance.
Yeah, this function is getting huge.
Oh, it's only used in one place. Okay.
Yeah. Pass the persist.raw down there. Let's already call the function. It's okay on no, it needs to be okay, but it's entry point dot emit. Pass the query.content.
We don't need to destructure this at all, actually,
And we
right?
need, there's a third argument, right?
And there is the
Sakura stuff.
options.sakura.
So
Um,
grab the Sakura options that I already forgot the label.
Actually, there's one more thing we forgot, which is the file name. And I think this should actually either receive a record or receive labeled arguments.
No, make a type for it. That's fine. There is another problem. Uh, we lost the Sakura options already, like processed because it's in that let star there. That means that we have to make a tuple thing.
It's in the let star.
Yeah, up there, all the way up there. You can go up. There we go. There. So no, more. Yeah, there. We are processing the options to see if the name is available, if you have Sakura files, all of that great stuff. But we should externalize those things. We should externalize those things. So here's what I'm going to propose. We return a tuple inside of a tuple. So there's the tuple that, which is the dependencies in the singleton. We need to return another guy, which is the options.
Can't we just,
If you
you
do
know,
that, we're going to have to remake the pair later.
remake the pair? Why?
Because we are using a single label on 44, and that label is being used down there.
Ah, that is true. Okay, let's say Sakura options. Uh, Actually, this needs to be if we have Sakura. Oh, this is just Sakura actually.
Yeah, that's just Sakura. The problem is the other branches. Line 47, for example. What do we put in there?
Actually, we can just use this, no? We don't need to do anything here.
But that's an option. We're gonna have to do the match again. I was
I
kind
mean, we're
of.
gonna have to do that anyways because this is in fact optional, the entry point, right? If
It
you're
kind of
compiling,
isn't because if you have a let's start,
no, it is because if you're compiling a program that doesn't use the database, you can just leave the options as an empty map in Erlang and you just don't use the database.
okay, you convince me then. Just do Ctrl Z all the way. Yeah, there we go. So you need to receive an option on the emit function. Just pass Sakura here. Yeah. And then in the emit function, we need to receive an option and do a match on it and stuff.
Okay, let's do this first, and this actually needs to be payload. This needs to be persist, which is a persist.raw. This needs query, which is an st clause head. This needs the options, which is options.sakura option. And this also needs the file name, which is a string. Right? And then
Probably options being only Sakura is not a good idea because we may pass other options to it in the future. Such
we
as, I
can
don't
call
know,
it
something for
Sakura.
the LFE probably.
We can call it Sakura. That's not a problem.
Yeah, just destruct the shit out of this now. Remove the types,
Okay.
put semicolons. Oh, that can stay actually. Query equals semicolon. File name. There we go. Okay, now we just need to bundle those things in the on the caller site. Persist equals that. Query semicolon. Oh, query.content, sorry, and then Sakura. Sakura and file name. Don't forget the file name.
The file name needs to be.
File name.
Would we have this?
File name.
We need this here. File name,
We don't need the equals.
and we don't need the equals.
There we go. Now let's go back to the function and. Ah, you're so close. Damn it. We are so fucking close now.
Line 74. There's a syntax error.
Oh, you need to do persist equals. There we go.
Unused, 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 unused. Everything is unused.
Yeah. Let's just create the tiny string, let it persist, and let's go. The first thing we should do actually is to try to define the start argument. So let start args equals. So match on Sakura. If it's none, then it's an empty list.
Actually, this should be a map
Uh,
because because here's the thing. If we go to the, I have a temporary file here. Wait, this is a take all. This is a take all. Let's go to
did you?
the fun start. There we go. Yeah, we receive two arguments here, right? We receive a map, which has the database configuration for now, but it's gonna have more stuff in the future, right?
Yeah.
And the goal, this is basically a reference to the query as a function object. So this is not determined by the Sakura options at all, which means we only have to concern ourselves with this map.
Yeah. That's okay. And I was just about to say, this is Erlang. This is not abstract format. So we need to be just write Erlang. So match Sakura if it's none, empty map. In
This needs to
quotes,
be
that yes. If it's some, then we need to create the map, probably using a fold or whatever. There's probably a function inside of the string module that does it. Or there should be. Maybe batteries have a more useful string functions.
Let's call this config, because that's the config map.
Yeah, that's fair enough. So if it's sum, destructure Sakura to grab the stuff.
Okay.
So there's an address, there's a port, semicolon, and there is
Why do
the.
languages need so much punctuation? This is really annoying, you know?
You only say that because you are a Lisper.
I mean, do you put commas between every word when you're writing English?
If they meant something that requires commas, I would. Uh, okay, what are we missing? There's more stuff, right?
There is the... I guess technically we don't care about the
Root module.
the root module at this point anymore, right? That's
Yeah,
used for compilation, but at this point it is no longer relevant.
yeah, that's only the executor concern. That's fine. So go back and semicolon underscore. Um, what are the names that the LFA thing is expecting?
Not this
Not
one.
that one.
Karuta.lfe. DB port, DB address, and there's also the timeouts, but we're not
We're
handling
gonna
that
ignore
yet.
timeouts. So DB port and DB address. Let's go.
Okay.
Enter point. We are so close. I'm excited. We are so fucking close.
DB ports. I'm pretty sure it's like this, right?
Oh, we need to do string interpolation in OCaml.
We do, yes. We certainly
So how
do.
do you do that, AI?
I mean, you can just
Okay,
concatenate stuff.
printf. Oh, do you prefer concatenating?
I mean, printf. If printf exists, we may as well.
Printf module as printf, which is probably FFI with C. So you're gonna, it's a C style. You know how to do it, right?
I do. It's mildly annoying, but okay. And this takes
Formatting string, and it's gonna return you another string. And it
wait,
takes
it returns on.
variadics arguments later.
I'm curious on how that works actually.
Yeah, this returns you a string, so you need to put this in a let. Oh, this is the return. This is already in a let. Okay, now you.
No, yes, but this takes the formatting string and then just the other arguments. Is that
Yes.
it?
Yes.
Wow, I'm pretty sure there's some serious compiler magic going on in there.
Well, I figured. Okay, but now we can just do the thing. So a bunch of percentages Fs.
Um,
Oh no, and percentage D, right? Because the port is a number.
right. How do you write a map in Erlang again?
Create mapping line in Erlang.
Lysium
It's
server
commas. It's commas.
maps. Oh, that's not commas.
Commas.
Okay. DB address.
The
Actually,
fat
the
arrow.
actually the part is a number. So number first, and then the DB address is going to be an actual string. Um, is this a number? Port is being passed to GenTCP connect.
We don't have LSP for that. Gen TCP Erlang. Let me find that answer of that to you.
I'm going to assume it's a number for now, but
Yeah, it's probably a number. The answer is... Wait, what? No, wait a moment. Which version of connect are we calling? 2 or 3
Uh,
arguments?
GNTCP connect 1, 2, 3, 4 arguments because we have the timeouts as
4.
well.
Okay, so the port is... it is a number, yes. Anything
Okay.
from 0, it's 16 bits.
Okay.
Okay, that's it. Now we need to we need to use config map somewhere. We're so close. Damn it. Do you have any drafts on how we used to do the call in the REPL? Because now that matters.
Not really. I do have, however, the call in the. Actually, I don't think we ever used start like that.
I don't think so.
Or-
I think we use start, yes, by hand. Check if any of the built-ins, like see if take call uses a start or whatever.
It doesn't.
Yeah, I think we use start at some point. I just don't remember when and how and things. But you are the coding master, so you have this under like on the palm of your hand. Anyway, so let's start the main because we have to have a main function.
We have to have a main function.
Oh, and do a let binding in the emit for the header for the shebang.
Okay, let's do that. Let shebang equals
I pasted
in.
I pasted in the chat the code sample thing. Okay. Next is the main function. It's gonna receive a unit. So main open close parenthesis.
Let main. Is it main though?
Yes.
Earl. I'm pretty sure. Yeah, you're probably right.
Yeah, but this needs to
Okay.
receive the body as an argument. This is gonna be an inner function because it needs to receive the what happens after the arrow. So main open close parenthesis. No, we don't need that. Don't need that. Arrow, a new line. Then the body, and then dot, I think. I'm assuming the spacing won't matter in this case, right?
It won't.
Okay. No, but you already are indenting it properly, which is nice. Okay, now we need to make the body to pass this function.
There's one thing that we may be forgetting actually. I'm pretty sure you have to do. Arguments can be specified. I don't think they have to be though.
I don't think they have to be. No, you
Okay.
just call it as a normal script. You do chmod plus x and just run with it.
Okay.
Now
Okay,
it
for
comes
the
the body.
actual body though.
The only things that I know is that we have to call start, we have to call an empty function, a function with no name, and we have to pass dummy arguments.
Okay, so what we need to do is, I guess technically, do we want to do a take all on the thing?
That would make it strict, right?
Isn't that what we want when we actually run the program? Don't we want to see something happen?
I guess that's fair. If you want laziness, you need to go to the future REPL. Like that's which doesn't exist yet, but we're gonna make it. So let's assume you want to do a take all.
Okay. Um, so basically,
Wait, what are we gonna do about the Karuta runtime in that case?
what's gonna happen is we're gonna call start, and maybe actually start should do a, because I'm gonna call a goal here. You see,
Yeah.
that's going to return a stream, and then I guess a take all goes around the start. Then,
No, it's the opposite, right? Take all takes a start.
well, yes, it takes a start, so it goes around it.
Oh, take all goes around it. I see. Yeah, no, that to me makes sense. But I
Okay,
have a question though.
okay,
This is assuming you have Karuta runtime, right? The entry point
yes.
must have access, which means that it needs to be qualified.
Karuta take all, Karuta start, and then we need to pass the map here first, right?
Yeah, so config map. You probably should do printf in here as printf. You take that, comma.
Config map, and then the query.
The query not gonna fly.
Let query equals in. Yeah, we need to grab this name and this arity and construct a fun expression, basically.
And what is that? A lambda?
Yeah, fun expression is basically, well, there are many ways to do that, but you can say, okay, I'm using a named function, like you do fun and then function name slash arity, basically.
In line 21, plug already the persist file name main. Oh, you need
There's
to
something we forgot. We also need the root module of the
It's already in Sakura, my
executable
friend.
here. No, no, that's the root module for Sakura. We need the root module for the executable, for the entry point, which is not the same module.
Ah, oh, that is true. Wait, isn't that already implied by the file name?
No, the file name is where we're going to spit out the contents of the executable.
Ah, in which root module of the program the query needs to be qualified with? That's your question.
Yes, that's what we need.
Yeah, no, just pass another argument. Put in the payload.
Yeah, we need to do. Yeah, here we need to include the root module.
No, wait, but this is gonna be the root mod. Oh, no, that's correct. Don't forget to put in line 7 as well in the type. Perfect. A bunch of unused. Let's go, let's go.
Okay, so we're calling start. So for the query, what do we need? We need it needs to be a fun, and then yeah, this needs to be a printf actually.
Yeah, it's so convenient. So convenient. Probably magic. And like I said, and like I told you in the chat, I don't mind the smart people giving us magic if we could do it by hand ourselves in a more annoying way.
So it's root module, and then the name, and then the arity.
What about the dummy arguments?
And what about the dummy? Oh, right. We actually need to apply this. We actually need to apply this.
Is there a repeat
In that
function?
case,
Let me see.
actually, we don't need the arity. We just need the arity to generate a
Yeah,
list of dummy things.
yeah. Oh, there is a way. Um, okay, so how you wanna do it?
Well, ideally, ideally, I just want to make a bunch of empty atoms, but I need to put commas between them because Erlang.
Yeah. So we kind of want. We used this function before for strings, don't we? Which is a fold that is a little bit smarter.
A fold, I think we do somewhere.
Try to search in the grep for string dot. String, like capital string, the module. Oh, that also works. There you go. Concat. Oh no, that's not it. That's not it at all. Okay, we are not doing that anywhere, apparently.
We are, but we have a list, is the thing.
No, but
We
we can
don't.
create a list out of nothing. That exists. It's called init. It's a function for a list module.
Okay. Let's just do that for now.
List create list same element OCaml. I'm just see if list is the init is the best way. Yes, they are talking about. Okay, do fun.const arity. I think that's
Fun.const.
arity.
Fun.const arity.
No. Sorry, fun.const dot the elements, the dummy values, the atoms. Sorry. Yeah, for the function fun.const and then the element that you want to. There it is. Oh man, the OCaml people they're gonna be pissed. I'm using const. Holy damn. That it's time. Persist file name at and let's concat the shebang and the main. Shebang main. Wait, what?
Main.ml
Oh, down there.
40.
No. Yeah, no. We need to pass two fun. This is a record now. This was supposed to be. This was a lambda before, but now it's a record. You need to pass. This is structured. This lambda, and we need to make the other one. No. The problem is the entire lambda, Marie. Wrap
Ah,
the
this
lambda in
one.
a record, and this is going to be structured equals. And you need to make the raw one now.
I guess
Fun
fun
name.
name body.
And
This is just
there should be
there.
inside of the Earl.compile there should be an example. So close.
Spawn compile process of Erlang program. Ah, yeah, no, the beam is actually writing the file.
Okay. Okay, so write a file. Uh, write string to file OCaml? The answer is that's so sad. We cannot just partially apply it. It's out channel module dot with open text. And if it wasn't because of the channel stuff, we would be able to just like eta reduce this. You need to pass the name first, though. Yeah. And
Okay,
then you
so
need
we
to
need
do,
to.
and then you need to do out channel again dot output string. No, out channel is underscore, not dot. Um, output string, and you receive the channel and the string, and you call it a day. Whew! Holy damn! Compile the plus module. Don't forget to remove the duplicated string. The duplicated query, sorry.
Oh yeah, we need to do that. Actually, here's a sanity check. That should error out now, right?
Yeah, good call. A module can have at most one query. First query defined here. Damn it! Look at it! Look at it! Awesome!
Okay, now if we do this, we should have.
I don't think it's gonna be there. I think it's gonna be in root.
Oh yeah, it's here.
Where is
We
it?
forgot to add the prefix, I think, to
Ah, yeah, it needs to
the.
be .url. Let's do that. Let's do that in the emit. Very easy.
Let's see how are my favorite clowns do.
Oh, you're gonna do it in the persist?
No, I mean we need to add this, right? This is the let prefix equals this, right?
Oh yeah, that's gonna be another CLI thing. You guys joined in a legendary moment.
Legendary.
Yeah.
Okay.
Okay.
Because we need to do this basically. Prefix
The slash.
slash and then the name.
Sure. And what about the extension? Go to the emit file.
Well, this
Go.
is an executable, so we shouldn't have an extension on
Ah,
Unix.
yeah, that is true. That is true. Go for it. Go for it.
Okay, we don't have a deal in here, but we do have one here. There's one thing that we should do just for the sake of being nice, which is we should make this executable automatically, right? It's just
Do you mean
can we
change
do
the
that?
permissions?
Well, yes.
Sure. Are you using single quotes on that? Does that work?
It does. This is the wrong.
Yeah, that column there is not correct.
Oh yeah, I know why. It's because let's go to the entry point here. We actually need the. We have the module name here, then the name.
Oh,
Oh,
this
the
is
name
always gonna
actually
be
is.
empty. That's always gonna be empty.
Well, yes, but just for the sake of sanity, let's do this.
Sure. Okay, how do you change the permissions of a file in OCaml? Change permissions of file
I
OCaml.
did that. I don't know when. Well,
Oh,
you
there
can
is a
always
Unix
just.
module. Easy. Okay.
Anyway, guys, sorry to go to bed. I need to wake up early.
Right.
No,
Good
don't
night,
leave. Don't
Magenta.
leave, Magetta. We are
What should
literally
I?
making history right now. Marinho, let's just change the permissions thing. Fast.
Actually, there's one more thing we need to do. For now, we should actually print the result here, right?
The result before persisting, you mean?
No, I mean the result of the stay call when we run the entry point.
Ah, yeah, no, that is true. That is actually true. Okay, no, okay, Magetta, go sleep, man. We're gonna tell you the tale later then.
Okay. Well, make a GIF for me and show.
It's because we are about to execute the plus program outside of the REPL, essentially.
Oh, that would be nice.
Yeah, so that's why I wanted you to stay because we are kind of in the moment.
No. Well, anyway, I need to
Yeah,
wake
see.
up. I need to
Go
talk
go
to
go.
a
Good
friend.
night.
Good night.
See you, one. And
See
thank
you.
you for being there today, Tevo. It's really nice help, man.
Thank you for what, sorry?
Bye thank you for Tevo for helping me today. That
Ah,
was really nice.
thank you, Tiff.
All right, see you.
See you.
See you, Magetta.
What are you looking for, Marinho? I want to be helpful.
I
Don't try.
want a function that prints out a term, an arbitrary term.
No, it's because it's gonna get fucked if we just do printf normally. Uh,
Should be in
how to
IO, right?
print a term to how to print a term Erlang. Oh, I found it. It is no, it is the function. It is an IO format. It is the same one that we usually use. It is IO format. You pass the formatting
Uh,
string and you pass a list of arguments. That prints a term.
okay, so we just say. Okay, so
IO format.
IO format.
Escape quoting now. Tilde p, tilde n, and
And
then
this
this
actually needs
is
to
inside
be.
brackets.
Yeah.
There it is. Cool. Cool,
To
cool,
the
cool,
P
cool.
is for 3D printing, right?
Um, P is pretty printing. Wait, no, no, actually, let me rephrase. If you use tilde p, it says any Erlang term and automatically breaks long terms into multiple indented lines for better readability. If you use tilde w, it prints the term in standard Erlang syntax, but does not add line breaks or indentation.
Okay, so we're formatting
Put a
the
space
output of
after the
this.
comma, please.
I'll put a space after the comma, okay.
Okay. Let's do the permissions thing. I found it. How to do that in Erlang. So there's a Unix module, not Erlang, OCaml. It's unix.cmod, chmod, literally.
I'm guessing that. Does OCaml have octal notation?
Yes, is 0 O. O, not X. Yes.
0, O. Okay, so we need to do. Um, read write executable. That's 7. Then just read is. Actually, it's not 7, is it?
7 is read write execute. Yes, you might
Read
want
write.
755 or 744 depending on whether groups and
What
others
is
should
the
admit it
least
or not.
egregiable and offensive one?
755 is usually what things set
Okay,
the
so there you
mode
go.
to
Compile,
when they
compile.
need to be executable.
Doesn't exist.
It's because the prefix is being done outside of here.
The
Now what?
prefix. What do you mean that? But that should work, no?
No, because the persist is persisting to another folder. Of course not.
I mean, I can do this. Uh, and, and that actually is supposed to work. See?
No. You're not getting. The prefix is not in the chmod, which means that runtime slash doesn't exist on line 28.
The prefix is being added outside of this function.
It is not. I think you're confusing because the persist function is smarter and is doing the appending for you, but the file name doesn't have it, which means that chmod
Ah,
doesn't know how to do anything.
I guess technically we could do this inside of persist as well.
That's a little sus because that means that persisting anything raw is making them executables.
Okay, let's change this. Instead of saying T and raw, let's say, or rather, instead of being structured and raw, let's say,
Executable?
I guess,
And I also I don't really like structured. I would say just, I don't know, library or beam maybe? Or program. And then the other one executable for sure. And then the executor is now mad. Of course it is. Not down, no. Yes. Yes. Now go back to main.ml because the construction is incorrect now. Structure is beam and raw is executable, and now we can do what you said. And this should be an let. And now you can grab the Unix stuff from there and put it in here. Parentheses, 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 parentheses,
yeah, this actually goes in here.
semicolon. Okay, anxiety. Let's go. Fuck. Um.
It's because I didn't save this.
Okay.
Okay, it's
Damn.
executable. And then, in theory, I should be able to do this, no?
Anxiety. We have to export main.
Main,
Fuck.
main needs to have, yeah, we need to export it, and also it needs to have, it needs to take one argument, not zero.
Script Erlang script example. Clanker, give me. You don't need to export it according to the clanker if you have a main with arity 1.
Oops.
That's better.
Illegal expression, let's see.
So there's some parentheses bullshit going on. Uh, I think it's inside of the brackets. How many arguments are you passing to the
Well, 3
sprintf?
to the
3?
sprintf.
Yeah, in line 24. How many arguments you have in there? True. And that's correct. That's correct. So, something is incorrect inside of the brackets. Here's the big question. Can you use an empty function call in Erlang?
You can, actually.
Really? If you say so. Because we are exploiting that because it was in the abstract format. But in here, this is Erlang, and we are using plus with empty shit.
Uh,
Okay,
there you go.
Marinho proving me wrong. Okay, so what is the syntax error?
Let's find out, actually. Uh,
We know Erlang. We should be able to pull this off. Illegal expression.
illegal expression. Okay, so we have IO format. This is a call. One, two, three. Oh, yeah, no, this is correct. 1, 2, 3 parentheses and 3 closing. We have DB port and DB address. Those are probably fine. Let's try this piece by piece. So if we do this, that works.
Yeah.
If we do, oh, this is not gonna work because I don't have plus. I mean, I guess we can like, how do you do it?
You can load
This?
the plus module because we have the beam for it.
Yeah, it works actually. It returns the goal for the query.
Why is this an illegal expression? Am I tripping?
If we
IO
do
format with
this,
arguments Erlang.
called with one argument. Okay, but this is not an illegal expression. It's just failing to run.
I agree. You do the same with the take call. Grab the take call and paste it in there.
I think I know what it is. I think we need to quote this.
No. Okay, interesting.
Let's finish this and deal.
Fuck. Okay, that's an improvement, but it still doesn't work.
Okay, let's see. What do we do here? Start blah 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 fun call go with we're fun calling the goal with the map, which is the initial state. We are fun calling the goal in here. Is that correct? It should be, I think. But is it actually?
Marinho asking himself.
Okay,
You
when
know
we
what we
take
could
off from
do?
a
No. But we
what?
can do better. We can experiment in the repo because we compiled to the beam the plus file.
Okay, if we do, yeah, the start is what's failing actually.
Yeah, no, but we need to
So
import the plus.beam. Remember that. I keep forgetting how the fuck you do that.
we don't. Like if we do this, it just works.
Oh, okay. So never mind.
Uh, okay,
Man,
so
this
start
is
is not
huge.
working.
I wonder how slow is the compiler is without that print of the AST. Like this is the moment where we're gonna know if we're gonna have to rewrite it in Rust, I guess.
That's not how you do it. Single Karuta, alright, because we need to actually quote this explicitly. If we do this, does it work?
We know that without the start it works, right? Because that's what you have in your temporary buffer there.
Yeah, this is saying that this is being called with one argument. This is being called with one argument. This is a goal which takes a state. Actually, I think the problem is how we're generating the query, maybe.
I don't think that's the case because this was working before. If you remove the start from the equation, you just do take all, I think it works.
If we just do take all.
I think we already tested this multiple times. And I think you have an example in the temporary buffer.
Yeah, no, that's the problem actually. The problem is that this we actually need to call the other. Oh man, that's kind of annoying. We actually need to call the other version. Where is
What is the
arity?
other version?
If we do this, I think it should work.
Remove the parentheses from arity though. We don't need them.
I just wanna do this real quick for testing. Deal. Well, it didn't give us a result, but it ran at least. It didn't blow up.
What an anticlimactic thing that just happened there. So we made all of these efforts to make an executable for 3 hours recording, and the end result is poof, nothing.
But yeah, I know what the problem is actually. The problem is when we generate the query and then we make the thing that is actually like the that we call as the entry point. Um, the second thing that we generate actually is not a proper goal because it doesn't take the state as an argument. The state of the Kanlen execution. I mean,
What does it
uh,
take then?
nothing. It's just it actually returns the stream already. Um,
So what do we need to
which
change?
we need to adjust how we compile a query basically. I don't really feel like doing that right now though.
Finish the recording.